We will continue with chapter 1 of pure maths in section 1.5, which is going to be about surds. So, as we know, anything to the power of 1 over m is a to the power of 1 and m. So we take the power of the number in the denominator, and the fraction is the power of the root of the surd. There are some rules that we have to learn. First rule is root a times root b gives root a times b. The other rule is that and note, root a plus root b are not equal to root a plus b. This is wrong. So this is what you have to know in general. Let's try out some examples. For example, here root 48 plus root 24. Here you have some rules or solving tips. Always simplify the surd in its simplest form. We will see here that root 48 is root 4 times root 12. Root 4 is 2 and root 12 is root 4 times root 3, which is 2 root 3 times 2 root 3, which gives you 4 root 3 plus root 24 is root 12 times root 2, which is root 4 times root 3 times root 2, so 2 times root 3 times 2. Okay, so here we get 2 root 6. So here we put 2 root 6. This cannot be simplified any further because the square roots are not equal. So you leave it out just like this. Let's try another example. Cube root of 512 plus or no, minus square root of 64. We know that 8 cubed gives 512. So you have root 3 and 8 cubed. So 8 cubed to the power of 1 over 3, okay, gives 8. So you have 8. And you know that root 64 is also 8. So minus 8, and this gives you 0. Another rule is that root a over b gives root a over root b. This is past. This is an important question in the book. It states that simplify root 75 minus root 12, giving your answer in the form a root 3. So we know 75 is equal to root 25 times 3. So that's root 5 squared times root 3, which is just the square root goes out with the square and you get 5 root 3. Root 12 is root 4 times root 3, which is 2 times root 3, which is 2 root 3. So minus 2 root 3 gives 3 root 3. Now, for the next section, and this is important, almost comes every exam, is rationalizing the denominator. When you have 1 over root a, you just multiply by root a over root a. So you get root a over a. If you have 1 over a plus root b, you multiply by the same, but you just change the sign. So a minus root b over a minus root b, which gives you a minus root b over. Now here you have difference. We can write this as a squared minus root b squared, which can give you a squared minus b. For example, one over root 3 can be written as 1 over root 3 multiplied by root 3 up and down to get root 3 over 3. And 1 over root 3 minus 2 can be written as 1 over root 3 minus 2 times root 3 plus 2 over root 3 plus 2, which gives you root 3 plus 2 over root 3 squared minus 2 squared, which gives you 3 minus 4, which is negative 1. So here you switch the signs, so it becomes negative 2 minus root 3. Let's try a harder example, okay, which is root 3 minus 2 root 5 over root 5 minus 1. Multiply by the conjugate, which is the denominator, but we just switch the sign. So root 5 plus 1 multiplied by root 5 plus 1 gives you, so the denominator is going to be root 5 squared minus 1 squared, which gives you 4. And the numerator is 3 minus 2 root 5 multiplied by root 5 plus 1. We just expand. 3 times root 5 gives 3 root 5. Negative 2 root 5 multiplied by root 5 gives negative 2 root 5 root 5, and then no, sorry, 5, then multiply by 3 gives plus 3. Now negative 2 root 5 multiplied by root 5 gives negative 2 root 5 squared, which is 10, and then minus 2 root 5. You get 3 root 5 plus 3 minus 10 minus 2 root 5. So that's root 5 minus 7 over 4. This is the solution.